is left hand side means this point, let us say that this point will be C minus H. So the coordinates of this point will be C minus H, comma, f of C minus H. Again, if you use the same formula, we will get limit h tends to 0. We are approaching C from left hand side. So limit h tends to 0, x2 minus x1. Let us say f of C minus H is the, y2. So f of C minus C by x2 minus x2 minus x1. Here x2 value is C minus H and x1 value is C. So C x2 value C minus H minus x1. Here x1 value is C. So if we cancel it, plus C minus C will get cancelled. Finally we get the formula limit h tends to 0, f of C minus H minus f of C whole divided by minus H. This is left hand derivative formula, and this one is our right hand derivative formula. This is what we saw in the previous class. I hope you can recollect it now. We will move on to the next page and we will discuss some more concepts here based on the differentiability, some more introduction concept. Okay, students. Now I am just going to read out the content in the Gupta and Bansal textbook. And one more important point is, a function has to be differentiable at a particular point, means it must be continuous. In case if it is not continuous at the particular point, let us say we need to check the continuity at x is equal to 10. In case if it is not continuous, means here you cannot draw tangent, here you cannot find out slope, because students, if it is not continuous at the particular point, means here, right, it is not continuous and we want to calculate continuity at this point, means you know that differentiability means we are calculating the rate of change. Rate of change means slope of the tangent. Here if so, for a curve at a particular point there will be only one rate of change. It cannot have more than one rate of change. But if you observe it, here I can draw infinitely many tangents like this. Tangents can be drawn. Do you understand this, students? In case I am just drawing the bigger graph, here it is not continuous, means this can be one tangent, this can be one tangent, this can be another tangent here also if you observe it. So if you observe it, here it cannot have a single rate of change. That's why the curve must be continuous in order to say that it is differentiable at the point. Students, are you clear?
Yes, sir.
Students, please reply.
Yes, sir. Yes, sir.
Yes, sir. It must be continuous, right? 1 minute more. It must be continuous. In case but we cannot say that all the continuous function at a particular point can be differentiable. The reason is, if you observe this graph, the modulus graph that is given in the Gupta and Bansal book. See, this is continuous graph only. We can draw the graph without lifting the pen. But here, if you observe it, corner is there. It is continuous graph only, but here corner point is there. And in a corner point, we can draw infinitely many tangents. When we draw infinitely many tangents, we know that it cannot have one rate of change. It can have more, it has more than one rate of change. Hence, it is not differentiable. So we can say that all differentiable function, I repeated, all differentiable functions are continuous function, but all continuous functions need not be, do you understand this, students? Need not be differentiable. Students, are you clear?
Yes, sir.
Students, please reply.
Yes, sir.
Okay,
Yes, sir.
so this is a very important point. Now I'll just read out the information that is given in the textbook. You can understand them very clearly because you are very clear about continuity concept. Now I read it out. Differentiability of a function at a point. Let D is an open interval in set of all real numbers and C belongs to domain. Then the first point is right differentiable function. A function f, 1 minute students, I will go move on to the next page. Right differentiable function, a function f from domain D to set of all real numbers is said to be right differentiable, right differentiable at x is equal to c, right differentiable at x is equal to c if it has to satisfy the condition if the limit h tends to 0, f of c plus h minus f of c whole divided by h exist finitely. Students, do you understand this? Students,
Yes,
do
sir.
you understand this?
Yes, sir.
Then left derivative means again a function f from domain set to set of all real number is said to be left differentiable at at x is equal to c if the limit h tends to 0, f of c minus h minus f of c whole divided by minus h exist finitely. It has one numerical value. That is what they say. Infinitely cannot be there. Finitely. Students, are you clear? This
Yes,
is
sir.
right differentiable, this is left differentiable. Okay. The third point is differentiable function. A function f from set of all domain to set of all real numbers is said to be differentiable at x is equal to c if it is both left differentiable and right differentiable at x is equal to c. That is, if both the limit h tends to 0, f of c plus h minus f of c divided by h and limit h tends to 0, f of c minus h minus f of c minus h exist finitely and both are equal. You know that these two must be equal to say that the function is differentiable at the particular point c. Students, are you clear about differentiability of a function in a single point?
Yes, sir.
Students, are you clear? You know that?
Yes,
Okay,
sir.
thank you, students. Thanks for the response. You know that if left hand derivative is not equal to right hand derivative means it is not differentiable at the particular point. And at the same time, if left differentiability does not exist, left hand limit does not exist means definitely it is not differentiable. Students, are you clear? Till now, whatever we learned in this
Yes, sir.
depends on continuity concept only. If you are very clear with continuity concept, studying differentiability will be very, very easy. Students, can we move on to the next topic?
Yes,
Yes,
sir.
sir.
Yes, sir.
Differentiability of a function in an interval. In a particular interval, we are going to check the differentiability. Let me draw the diagram now. Just roughly, I am just drawing the diagram. Right, we need to check the continuity in an interval. That means in between this point, in this interval, let us say in this interval we are going to check the continuity. Let us say this point is a and this point is b. So we shall now discuss the differentiability of a function in an interval. Differentiability function on open interval. It means that open interval means the endpoints are not included, a and b are not included. A function f is said to be differentiable on an open interval a comma b if f is differentiable at every point of a comma b. It means that it has to be differentiable in each and every point excluding a and b. Without including a and b, if all the points in between a and b is differentiable means we can say that it is differentiable in an open interval. Students, are you clear? Students, are you
Yes,
clear?
sir. Yes, sir.
Okay, students, thanks for the response. Now we will move on to the next content here. differentiable function on closed interval. A function f is said to be differentiable on a closed interval a comma b. Closed interval means here both the limits, both the extreme points are included here. You know that f is differentiable at every point inside a and b here, and then f is differentiable, right differentiable at x is equal to a, because the curve lies, sorry, the interval lies in the right hand side of a. Hence at this point a, the differentiability must be right differentiable. Students, do you understand? Students, do you understand this?
Yes,
So
sir.
that is what they say, that it must right differentiable and the value must exist finitely. And then you know that at the point B, in order to check the continuity of an closed interval, means at point B, the curve lies in the left hand side. Hence, f is left differentiable at x is equal to b. That means limit h tends to 0, f of b minus h minus b minus f of b divided by minus h exists finitely. Students, are you clear with open interval differentiability, closed interval differentiability concept? Students, are you clear? Please reply.
Yes, sir.
Yes, sir.
Yes, sir.
And the final concept is everywhere differentiable function. A function f is said to be differentiable everywhere if f is differentiable at every point of the real line. I hope you can understand this. And then if there are some important theorems, that is that here proof is not given, it is beyond our textbook knowledge, so I'll just read it out. Let f and g be two real valued functions such that real numbers g is differentiable at c. That is, sum of two differentiable functions is also differentiable. We have seen this kind of problems in continuity concept. We are just extending the concept in differentiability here also. And then next one is f minus g is differentiable at c. That is, difference of two differentiable function is differentiable. And the third point is product of two differentiable functions is differentiable. And the fourth point is quotient of two differentiable functions is differentiable. And next one is let f and g be two real valued functions such that f circle g is defined and g is differentiable at c and f is differentiable at g of c, then f circle g is differentiable at c. That is, composition of two differentiable function is differentiable. And the last important point, if a function is differentiable at a point, then it is also continuous at that point. Converse may not be true. That is, a function, if a function is continuous at a point, then it may not be differentiable at the point. We already discussed this point. We have completed, students, with this we have completed the introduction of differentiability. Now we have to solve problems. We have solved many problems based on this concept. Only the formula has to be used. The rest of the concepts will be same as continuous concept and continuity concept only. Students, can we proceed to the problems?
Yes, sir.
Students,
Yes,
okay,
sir.
you can easily understand all these problems. I'll just teach you one or two problems. After that, you have to solve the remaining problems on your own. Okay, students. The first question is, show that the function f of x is equal to x square is differentiable at x is equal to 1. F of x, show that f of x is equal to x square is differentiable at x is equal to 1, and hence find f dash of 1, right? This is the question. Now we need to find the differentiability at x is equal to 1. Differentiability at x is equal to 1. First we will find out right hand differentiability, otherwise right differentiability. at x is equal to 1. At x is equal to 1. It is denoted as right hand derivative. You know that a function is, we are doing first derivative means we will write f power 1 at x is equal to 1. So we are just putting this 1 here. And then we know the formula for right hand derivative, that is f of, limit h tends to 0, f of c plus h minus f of c whole divided by h at x is equal to c. Is equal to 1. Hence we can write the formula as limit h tends to 0, f of c plus h. Here c value is equal to 1, hence 1 plus h minus f of 1 whole divided by h. Here for the function f, we are giving 1 plus h as an input. Here the function is equal to x square. Hence we can write this as limit h tends to 0. We are giving 1 plus h as an input for x square function. So it becomes 1 plus h whole square minus, and this here 1 is given as an input for the function x square. So it becomes 1 square whole divided by h. And it can be simplified as limit h tends to 0. There are two ways. You know that it can be simplified as a plus b whole square formula, and then we can subtract 1 from it. Otherwise, we can apply the formula a square minus b square formula as well. Right? Here in this book, they have used a square minus b square. Hence, I use the same thing. So a plus b, here a value is this and b value is this. So a plus b into a minus b. 1 plus h minus 1 plus 1 and minus 1 here will get cancelled, whole divided by h. So limit h tends to 0. If you observe 2 plus h into, so 2 plus h square, sorry students, here 2 plus h into h whole divided by h, and h will get cancelled, and we can use direct substitution technique and we get the final answer as 2. Students, are you clear with this? Students, are
Yes.
you clear? Please reply.
Yes, sir.
Yes, sir.
Others, only 4 or 5
Yes, sir.
students have replied. What about others?
Yes, sir.
Did you all understand?
Yes,
Yes, sir.
sir.
Okay, now we will calculate. Thank you, students. Thanks for the response. Now we will calculate left hand limit value. Left hand derivative. Left derivative at x is equal to 1. So limit h tends to 0, f of c minus h minus f of c whole divided by minus h. Here c value is equal to 1, hence limit h tends to 0, f of, in place of c we are putting 1 minus h minus f of 1 whole divided by minus h. Here function is equal to x square, hence we are giving 1 minus h as an input for that function. So it becomes 1 minus h whole square minus x square is the function. We are giving 1 as an input. So it becomes 1 square whole divided by minus h. So it becomes, again we can use the same formula, limit a square minus b square formula. So a plus b into a minus b, right students? So it becomes whole divided by minus h. So limit h tends to 0, 2 minus h, and then plus 1 minus 1 will get cancelled. We will have minus h, and in the denominator also we have minus h, and then we can use direct substitution technique. So we get the final answer as 2. So left derivative is equal to right derivative, which is equal to 2. Hence f is differentiable at x is equal to 1 and f dash of 1, that is derivative at x is equal to 1, is 2. It means that when the input is 1, the output changes by 2 units. Students, do you understand it? When we keep on changing the input by 1 unit from 1 to 2, 2 to 3 means the output, the rate of change will be 2 units. Students, are you clear with the problem that we discussed? Students,
Yes, sir.
and if you observe the remaining questions, all the questions are based on the continuity concept that we discussed. Only extra step what we do is here we apply formula. All other steps are same only. First, anyone talk with me? Do you have any doubt? Did anyone say something?
No, sir.
No, sir.
Can you try
No, sir.
to solve all the remaining problems on your own? You just go through
Okay, sir.
Gupta and Bansal book. I am damn sure that you can solve it on your own if you are very clear with continuity. Students, if you have doubt, please send me SMS through WhatsApp. I will get back to you. Otherwise, we will have discussion tomorrow in the next class. We will have discussion about the problems. Students, are you clear?
Yes, sir.
Sir.
So with this, students, I am telling very clearly that with this we are completing differentiability concept. Tomorrow we are going to start relation and functions. I am not going to start from the beginning. I am going to start the concept where the Ramesh sir has already taught. Okay, from that point I am going to teach you. Students, are you clear?
Yes, sir.
Sir.
Yes, sir.
Okay, students, you have to solve all the problems as homework. Tomorrow we will have relation and function concept discussion. Okay, students, thank you. Thanks for the cooperation. Study well. Don't waste the time. Okay.
Thank you, sir.
Thank you, sir.
Thank you,
Okay,
sir.
sir.
Thank you,
Bye,
sir.
sir.
Okay.
Thank you, sir.
Thank you, sir. Thank you, sir.
Thank you, sir.
Okay, Bob.